Okay, welcome to the January 20th CERIAS seminar. Chris Clifton, in addition to being the instructor of record for the course, will be your speaker today. I'm coming back here to Purdue. I've been on the faculty since the beginning of the millennium. I've back here after 2.5 years at the National Science Foundation. And what I'd like to talk about today is data privacy. Privacy and security go hand in hand. It's very tough to protect privacy if you don't have data security, as those of us who have spent some time working for the federal government know firsthand. If any of you have ever done security work where you had to get a clearance, you know just how much information you have to give, and because of poor computer security, much of that information is now who knows where. However, privacy really introduces some new challenges, and a lot of the way we've thought about privacy in the past is very limiting, and what we're beginning to see is it really doesn't cover all of the concerns and challenges. So I'm going to go into a couple of examples of some work we've done here at Purdue, and then kind of open this up for hopefully some brainstorming on what some challenges and issues are and what we might do in the future. So what is privacy? Well, the first example might be complete secrecy. But that's not really possible. If nothing else, you learn that I want something, otherwise I wouldn't have asked. So the real problem with privacy is what can we achieve in terms of I keep my information from being used, seen in places I don't want it seen, and yet it still gets to be used in ways that I do want. And this is where it gets to be challenging. So one of the kind of traditional measures of privacy that's written, in fact, very explicitly into a lot of laws, particularly US law, is anonymity. You may have all the data about me, but you don't know who it's about. You can't link the data to me. So the idea is that protects privacy. You can't, you don't know it's my data, so you're not violating my privacy. Interesting counterpart, how many people feel that this is really an adequate view of privacy? If you have complete anonymity, your private data is out there, but nobody knows it's you. Is that enough? Yeah, there's people who would disagree with that. And as an interesting counterpart, suppose we're talking, instead of personal data, we're talking about intellectual property. If you were a company and your intellectual property were out there for all to see, but they didn't know whose it was, would you feel good about that? No, that completely misses the point. Well, to some extent, people feel that way about their private, personal data as well. So anonymity, it's not only is it not enough, but worse yet, it's really hard to get. Back in 2006, a decade ago, we had an example where AOL released its customer web searches for research studies. 20 million queries among 650,000 unique users. They replaced the user ID with a random number. So this is anonymous data. Well, most of you are probably old enough to remember what happened. A New York Times reporter tracked down a person and said, "Oh, are you user 14587? Is this you? Are these your queries?" And the answer was yes. including some things that someone might find embarrassing, but also some queries that were specific to location, specific to name, quickly allowed them to track down who wrote those queries. You don't want to be the person who is responsible for something like this. And it just keeps going. Netflix is an example where it was shown how to re-identify where it wasn't actually reporters doing it. Very recently, New York City released taxicab data. And it was quickly shown how it would be very easy to identify individuals, both the taxi drivers and the passengers in this data. Interesting, Uber responded when New York City said, we want that same information from you. Uber said, well, we'll release it in an anonymous manner. And actually had some very good ideas about how they could do this. New York City said, no, we're going to release it in the same way we did for the taxi data, even though that's a violation of people's privacy. It's interesting, interesting situation there. So, how do we provide anonymity? How do we avoid some of those things? Well, there's some notions of the kind of two classes. One is syntactic anonymity, and the other is noisy information. So if I can add noise to the data in a way that hides who an individual is, this provides sufficient anonymity. Or if I can come up with some specific approach. So for example, k-anonymity says, I'm going to release the data, but I'm going to generalize. Rather than giving a birth date, I may just give a year of birth. Rather than giving an address, I'll just give the zip code. And in k-anonymous data, that means that in that identifying information you give about people, there's at least k people who look identical. Unfortunately, if you give a list of k people and under classes you say they're all in the security seminar, even though that metadata about them that you could identify is the same, you still know they're all in this room. And if you're a stalker, you're going to be able to find them. L-diversity said not only do we have to have that k-anonymity, but there has to be diversity among the sensitive information. Of course, this is challenging. You have to, first your data doesn't look like the original data. You don't have addresses, you just have zip codes, for example. And second, you have to define what is identifying information. How do you know what might be identifying and what might not? It may be that being in this course in some senses could be sensitive, but in others it could be what identifies you. So there's a challenge here. Some of these noisy information methods can get around that, and actually when you talk about public use microdata sets they put out, for example, by the US Census, one of the ways they will protect them is adding some noise to the data while still preserving certain statistical properties. So you go out and try to find someone, there is nobody that exactly matches that data item because it's not quite real, but it's close enough to use for statistical analysis. Differential privacy is a more kind of formally defined way of doing this. So, what are the problems? Well, can we really prevent re-identification? Our experience is no. We keep trying to anonymize data and people keep breaking it. Variety in the data just makes this worse. Assume we can. Is the data still useful? We've actually got a study underway where we're shadowing a study and repeating the same analyses on anonymizations of the data to see what happens. We're currently having some serious issues with anonymizing a city-sized health information data set. Even with that many people, even with hundreds of thousands of people, you end up losing a lot of information, and it's tough to do any sort of interesting studies. So as far as noise addition, epsilon differential privacy is a way of dealing with this that has really hit the research community about a decade ago, and we've still been figuring out the details, figuring out how to make this work in practice and how to use it. The idea behind epsilon differential privacy is, let's assume that we have a data set, and what we're going to do is we're going to calculate some function on that data. We're going to do some analysis. And the results of that analysis are going to be very close to the same even if we remove a person from the data set. So, we have our normal way of doing this, but by adding some noise to this, well, maybe we can hide that individual impact. And the key idea here is that we want to be able to remove an individual, and essentially the answer is probably going to come out the same. The impact of one individual on the answer is less than, or small relative to the amount of noise we're adding. And yet, the answer as a whole is, the noise is small relative to the answer as a whole. So for example, if you were to compute the sum of the ages, or the average age of everyone in this room, I could add 100 to the sum. It's not going to change the average much. But any individual is going to make less of a change than that. The key is it has to work for any individual. It doesn't matter which individual we remove. And what's more, it needs to, for the differential privacy mechanism to work in general, this needs to work for any pair of databases. Otherwise, from figuring out how much noise might have been added, you can figure out which database, what the original database was to figure out how much noise you might need. So it turns out that there are some problems which are very difficult to provide differential privacy, some problems that are easy. The idea is what you're really getting out of this is you're getting one answer, but what you're really getting is a point in a distribution. And you know that the point in the distribution is a little bit, if you think about one point, the actual answer you get, well, it could be from either the red or the blue distribution. There's just not that much difference between the two of them. And it's going to be, the mean of this is going to be very close. In fact, most of the time it's pretty close to the true answer. Sometimes it's off. But that potential for it being off sometime really completely hides the impact of any one person. The nice thing about this is we don't need to worry about what's sensitive, what's identifying in an individual. This, no matter what that function is, this analysis, you don't release the data, you release the analysis. Now there are ways we can do this where the analysis is give me a data set that looks like the real one, and you actually can release things that look very similar to the real data. But in practice, it works best where you say, I'm going to use this to compute some value. So if you want to know more about differential privacy, you should have been here a couple of years ago when we had Christine Tass gave a tutorial on differential privacy. But since this is the CERIAS seminar, you can go back and look at that tutorial. 2 or 3 years ago, well, 3 years, no, it was at least 3 years ago, and it was Christine Tass gave a tutorial on differential privacy. But, you know, what is privacy? Well, if you look at the US, a lot of this goes back to a paper by Brandeis, where he talks about the right to be let alone. Actually, Warren and Brandeis. They talk about the right to be let alone. This is Supreme Court justice. From an information privacy point of view, you know, my information is protected in a way that it doesn't adversely affect me sometime in the future. So it's really, it's not so much that you care that the information is known as the fact that that information is known by someone else affects you. Now, in some cases that may be a direct effect. They don't give you a job because of it. Or, you know, in other cases it may be much more indirect. Because someone knows something about you or may know something about you, you find it hard to look them in the eye. You know, these are all things, it's, you know, often these things are very difficult to measure. So a lot of it is about control over the data. The data should only be used in ways that you approve of. Sometimes you may not approve of a use of a data that has nothing to do with a direct effect on you, but it has an effect on society that you may not be happy with. I don't want my data used in ways that control advertising, so some of you see certain ads, others see different ads that stratify society. Interesting example is men and women see different ads. This was looked at, and actually there was a study of job ads and found that women tended to see ads for lower paying jobs. Well, you know, they started doing some further study. What I've heard of the reason behind this, it's not that they weren't showing the job ads to the high-paid job ads to the women who were appropriate for them. It's that other places, cosmetic manufacturers, were saying, okay, here's a high-income woman. I want to show them an ad, and I'm going to pay more for that ad than the person who's offering them the good job. But the end result is, you know, this could lead to people not getting jobs that would be very appropriate for them because they don't know about them. I don't want my data to be used for something like that. So how can I control that? It's not affecting me directly, certainly not hurting me, but it's hurting society. So, you know, a lot of issues that come up. Disclosure of information, you know, disclosure sharing. I want the data to be used for things that I want. I don't want it to be disclosed for things I don't want. You know, what's the approved use? And recourse. What do I do if my data is misused? How do I even know that it's being used in ways I don't approve of? So these are, yeah.
So this raises an interesting question because, go ahead and use your mic. Sorry. This raises an interesting question because with the potential...
Did you turn the mic on?
It is now. This raises an interesting question because with the potential for big data, in the spirit of trying to squeeze more accurate answers with less error due to differential privacy and the cumulative tolerance that can result therefrom, are we saying the individual should basically withhold, or as individuals we should withhold from society information because we fear it might be used against us? And does that individual desire override society's greater good? Okay. So, part of the issue is a policy, cultural thing, is making that call. But let's assume we get to the point where everyone says, well, if my information could be used to the greater good, even though I may not be delighted with it every single time, how do we then maintain that privacy? So I just had to point that out because we can obsess on what every individual wants and never get anywhere.
Yeah, I mean, it is an interesting, and as an individual, most people are very happy to give up their personal information for some purposes. In fact, someone offers you a very small benefit, you'll probably give up all kinds of personal information. And actually societal benefit. People are willing to give up data for cancer research or for all kinds of other things. Very willing to do it. It's, the difficult thing is how do you make sure that you still have that control, that it's used in ways that you're happy with. And if the only answer is to withhold data, to become a hermit, well, yeah, that's not good for society or individuals. If, on the other hand, you had some obviously very complex way of doing things where you could specify, oh yeah, it's okay to use my data for that. No, it's okay to not okay to use it for that. What would the end result be? The problem is, how often does your data get used? Could you really get asked every time? Would you want that? So I don't think that's a practical, but it might be an interesting thought experiment. What would happen if every time your data was used for anything, you were given the opportunity to make a decision as to whether you wanted that to happen or not? And you were actually told what the impact would be of your making that decision. That's an interesting thought as to what would happen. How often would you say yes? How often would you say no? Obviously, that's not the way things would work. But that's one of the key challenges here in privacy is there are so many different issues that come up. There's some interesting outcomes, though. For example, polling. Political polls, people are known to give information that it's known that poll results and the actual election results are going to have differences. And in particular, candidates with extreme views often do better than the polls say they will. And there are some clear reasons why this happens. The same is true. How many of you have ever given incorrect information when asked to register at a website? Yeah, half the class. So, when you're getting this big data coming in at a website where you're asked to register, can you really trust that data to do your analyses? If half the people are giving bad data, you have to start thinking about what, if you can provide promises of privacy, Does that mean you get better data and better answers? There's some interesting questions that come up. And another is, can we come up with weaker views of privacy? Often this anonymity, differential privacy, just make it very hard to get good data. But if you just say, okay, it's a free-for-all, that also makes it very hard because people won't want to give you good data. So here's a couple of examples of some work we've done with somewhat weaker views of privacy. So either you aren't sure what I want. You may know who I am, but you don't quite know what I want. Or you aren't sure who I am. You may have some idea. So this idea of plausible deniability. So we've looked at this in the concept of text. Because, for example, even with something like search queries, but much more with something you've written, a notion like k-anonymity makes no sense. Okay, I'm only going to release the letter you've written if there's several other people who've written exactly the same letter. And, this isn't likely. So here's one example, was a location uncertainty example. And I think I have to click to get that to. So that was actually at a conference where I gave a talk on this, where that was showing what was being reported by the GPS in a tablet. And you'll notice there is a point that it says is the point, but there's also a circle where it says there's some uncertainty with this. And so the idea is, could we use that to say we're going to give some uncertainty? We're going to give an incorrect location, but we're going to give a level of uncertainty that you're somewhere in that space, but not necessarily at the center of it. And what would that do to existing location-based services? So we did some analysis of this and said, let's look and see whether, in this case, Android apps are using this. And there is a very simple get accuracy call. And so we looked through a bunch of Android apps to see if they used this get accuracy at all, or if they just assumed the point they were given was correct. And some of these actually did. There are several that actually made use of this. You can certainly see it would be obvious how you might make use of it in something like Taxi Magic. Well, yeah, if you've got a very uncertain location, you probably don't want the taxi to just go there when you might be half a block away or on the other side of an alley. I talked to an Uber driver who's run into that problem of being directed to pull into an alley to pick someone up because, well, they were really on the street on the other side. So these are ones that actually did look for query for uncertainty. They actually had code to call that get accuracy. How many of these actually sent that back to the server, did something with it? Well, very few. And there were only 2 that we were actually able to detect an impact on the outcome of all these location apps we looked at. So Yelp and Foursquare are basically both doing check-in, and they were using it to say, are you really at that location? In the case of Foursquare, they said if the reported uncertainty was high, they'd look at other aspects before they'd allow you to check in. In Yelp, they say if what you say is your location is within that reported uncertainty, then they're going to believe you. In other words, they're saying it's the GPS that's not trustworthy. That latter, hey, that would work. You could wait until you'd left an place and report your check-in with high uncertainty, and your stalker's not going to find you because you've already left before you check in. So this is actually several people did this, and that picture this was done at a Dagstuhl seminar. That is Schloss Dagstuhl in the picture in the corner. And guess what? We weren't out in the field when the iPad that this picture is from was reporting the location. It was barely within the uncertainty space of that circle. Okay, so another idea where we're using this uncertainty is text generalization. So here we're looking at the concept of de-identification, things like protecting against author identification, protecting against releasing things that have very specific information that identifies you. But at the same time, de-identification tools get rid of obvious identifying information, but often there's things in the text itself that make it unique. So for example, how many of you know what phantom pain is? A few of you do. Phantom pain is what you feel when you've lost a limb and it still hurts. If you put in a medical record someone has phantom pain, well, there are some cases where it's not loss of a limb, but generally that means they've lost a limb. Well, that's kind of identifying, but it certainly doesn't match any of the identifiers we would list as identifying information. An alternative, we can suppress sensitive information. Instead of say uses marijuana for pain, we could say uses, well, if we suppress it entirely, that doesn't look very useful, does it? So our idea was to generalize that. Instead of saying uses marijuana for phantom pain, which is certainly not something you would want known if you were the person responsible, because, hey, it's both sensitive and identifying, at least in this state. Information generalization, well, we'll get rid of some of the identifying, but also some of the sensitivity by generalizing information. And yet we'll retain some of the useful analysis. So this was an attempt to do this, to generalize. And basically we could use a hierarchy of words. We actually can get that from various ontologies, such as WordNet is a simple example, but there are much more complex and semantically valuable hierarchies. And rather than just sanitizing by scrubbing out or redacting the bad information, we generalize it. So that's an example of making information less sensitive, less identifiable, but not perfect. Another approach to doing this is kind of hiding the real information in noisy information. This was an idea that we came up with to protect queries. The idea would be that the browser submits more than one query. Which one's the real one? So deniability, the key is regardless of which was the real query, you get the same set. So any one of those could have been your original query. There's no way to prove which was the real one. In addition, you want those cover queries to be diverse topics. You don't want to give a whole bunch of queries about the Super Bowl, because that's going to give the information away anyway. Finally, and this is the hard part, plausibility. You want the queries to make sense. So, Java compiler, Newton Apple, for those of you old enough to remember the Newton, these are both things that make sense. Java compiler and Motorola table, what's Motorola and table? How do those go? Why would those go together? So this is an example of an implausible query. So you wouldn't want to give those. So the theory behind this is that user queries follow some distribution, and cover queries are generated through some distribution. And we want to be able to say that the probability of these two events, where Q1 is the user and Q2 is the cover query, and Q1 is the cover and Q2 is the user, are the same. And this essentially gives us a formula that, based on the distributions, that we have to meet. So then we have to come up with some way of doing it. And we tried a couple of ways. Because of the time, I'm not going to go into a lot of detail, but one approach we used was based on latent semantic indexing, which is a technique used in information retrieval, where we essentially generated queries from the things that would be good queries for the data that you had. So if I have a query that's going to return 100 documents, I should be able to generate queries that also return 100 documents. This has turned out to be very difficult. Did some work here. A second similar approach was to use a query log and generate queries that were similar to the terms in the query log and with similar frequencies. So, here's an example of some sample queries that we came up with. And this is actually interesting because one of the things that makes the problem hard is queries tend to be in a sequence. You give a query, it's not quite what you wanted, you give another similar query. And then at some point you give something completely different. And we need our sequence of cover queries to match that as well. So any idea which of these is the real query? Who would guess the first? None? Second? A couple of you? Third? None? Maybe one? Well, some of these things are pretty obviously real things once you do the stemming. Some of them actually seem to be related terms, unrelated. Turns out that in that one, the third example was the correct one, but it worked out pretty well. So I'm not going to go through the details because I want to get on to some other things, but essentially the same sort of probabilistic argument works for sequences that works for the regular queries that we showed before, where you eventually have this event being a sequence, and it needs to be equally probable for the cover and the non-cover. So here's another example of some queries, these taken without the stemming. Again, guesses? Actually, the third is the real query. The others are generated sequences. So, there's just a couple of examples of things you can do when you start thinking beyond simple views of anonymity, secrecy. One of the things about all of these, you weaken knowledge about the user, either through not knowing who the user is or not knowing what's true about that user, which weakens what you can learn about the data. And this is something we've been working on. How do we better learn from anonymized data? So this could reduce the utility. This leads to resistance. I heard someone once basically say to differential privacy, how many babies are we going to kill with differential privacy? Is that the measure of epsilon, the privacy measure? What people making these statements often forget about is the fact that there's already noise in the data. Your data is not perfect. And adding a little more noise, often it's a very small amount relative to what's already there in the data. So, when we start talking about these things, people can go off the deep end and not think about what's really going on. But, are there other ways to provide privacy? Are there other things we should think about? And this is something to think about this and what we should be doing in terms of protecting privacy. I'd like to go back to some of the laws, guidelines, and rules, and understanding some of these can help, I think, give us some ideas. So some of the things that the EU Data Protection Directive, which is 20 years old now, provides: the right to know where data originated. In other words, if they've got data about me, I have the right to know where it came from. I have the right to fix inaccurate data. In the event you do something illegal with it, I have a right of recourse. In some circumstances, I should have the right to withhold permission to use that data. Not necessarily in all circumstances. And these circumstances are defined as part of the rules. One of the things they do say is anonymity. If the data, personal data, is information that can be traced directly or indirectly to a specific individual. And if it's not personal data, in other words, if I can't trace it to an individual, it's not covered by the law. Unfortunately, as we've been discovering, data is traceable to individuals. In fact, the number of things that the EU considers personally identifiable data keeps growing. A number of years ago, IP address was added to the list. And all of a sudden, all of your firewall logs become personally identifiable data and covered by this law. But think about it. IP address individually identifiable? I mean, I don't think any of you would take that long to find the IP address of the desktop machine in my office. In fact, probably several of you can trace through your email logs and figure it out while we speak. They then say use is allowed in certain circumstances. If unambiguous consent is given, if in order to perform a contract with the subject of the data, it's required to have that data. In other words, if I want to buy something from you using your credit card, I don't need your consent to have the credit card data, you've given it to me to perform that contract. If it's legally required to have that data, you can have it. If it's necessary to protect the vital interests of the subject, if it's in the public interest. An interesting difference here. In the US, Google will say everything we do is in the public interest. It's all for the good. Now, in the EU, public interest tends to mean if the government's doing it. Or if it's necessary for legitimate interests of the processor and doesn't violate privacy. That's pretty open-ended. Doesn't violate privacy. What does that mean? The definition of privacy is it doesn't violate privacy. There are some uses that they specifically prescribe. There are certain things that information you're not supposed to be using or revealing. They say that you have to make data available to the subject. In particular, in some cases, you have to give advance notice and right of refusal. And they limit the use for automated decisions. You can opt out of automated decision makings. That things like the use is legitimate and safeguards are in place to protect a person's interest, it's up to the processor of the data to show that. Not you as an individual having to prove that they misused it. And logic involved in decisions must be available to the affected person. I always wanted to go to Europe and go to Fair Isaac Corporation and say, hey, I want your algorithm. Under EU law, you have to tell me the logic involved in decisions. I want to know exactly how that credit score is computed. Might make an interesting case. Not a good computer science project, though. And I suspect a legal project that would not win in the long run. Several examples. The US is a little bit different. We don't have an overarching privacy law. We have sector-specific laws. HIPAA is one of the more well-known. Health Insurance Portability and Accountability Act. And part of it is these safe harbor rules, which are somewhat unique in law. They specifically say there are 19 identifiers. If you remove those, then the data is presumed to not be identifiable. And some of these are generalizations, like location, you're allowed to use the first 3 digits of a postal code if that first 3 digits includes at least 10,000 people. Dates, nothing finer than a year. Well, there's also a clause in there that scares people a bit, which is you have no other reason to believe that the data is identifiable. It's written in law, it's okay to plead ignorance. I don't think people are, so you don't find a huge number of data sets that are released under safe harbor. What people do is they tend to release data under a data use agreement. It's not made publicly available. It's made available just to people who sign the agreement. But these are very specific and just talk about very narrow interpretations of privacy. Going back actually quite a bit farther in the past, we have the US Fair Information Practice Principles. These aren't rules. They are guidelines or aspirations. And looking at these, I think, gives us more ideas for where privacy research should be going. So, transparency. Organizations should be transparent, should notify individuals about what's going on with the data. The individual should be involved in that process of using personally identifiable information. You should talk about the purpose and articulate why it's okay to use for that purpose. You should only collect data that's directly relevant and necessary. Which all the people talking about big data, it's like, no, I want to collect everything because I don't know what it might be useful for, but it might be someday. And that flies right in the face of the FIPS. You should only use it for the purpose specified in the notice. You should ensure that it's accurate, relevant, timely, complete. You should protect it. And you should be accountable and auditable. Make sure that you've followed these principles. A lot of very good ideas, and when we look at it, you find there's a lot of things that are important in here that existing privacy research doesn't even touch. So I think this opens up a lot of ways that we should think about what, just by going back to the 70s and thinking about what people talked about then, that open up new ideas for what we can be doing today in terms of providing privacy. 40 years. Some other examples. In Canada, they have PIPEDA, which is a general overview law. And they have some interesting statements. May collect, use, or disclose personal information only for purposes that a reasonable person would consider are appropriate in the circumstances. Again, very hard to say what that is. It's one of these, well, I know it when I see it. And they have several more specific principles, very detailed. Another one that I think is very good is the Australian privacy principles. If you're interested in going into research into privacy or looking at new ways of thinking about privacy, they give, one of the nice things about the Australian privacy principles is they actually give examples and how the law ought to apply to those examples. And so there's some very interesting information in here. And again, they talk about many of the same things that we see in these other principles. But also in some of it very specific, some of it less specific. And, okay. But I think we can even find some things going beyond this. So we did a study of privacy preferences in collaborative search. So the idea was you're searching, you have several people who are collaborating on a task, and you're using one person's search results to help another. And this was a search engine they were building. And they started looking and saying, what about sharing? How is this information shared? What are the privacy? How does privacy affect this? So what they did was they said, people don't know, they don't even have prior expectations in this. They're using it in a variety of real scenarios to help in getting feedback on that tool, but at the same time, let's try to find out what they really want in terms of privacy. So they just said, tell us what you want. Not, here's a language, specify them in this language, not which boxes do you check. Just tell us what you want. And the policies were then analyzed manually to figure out what this meant. Some interesting things came up that don't show up at all in any of that previous discussion. So for example, one that came up consistently was reciprocity. I will share information with people who will share the same kind of information with me. You see that nowhere in any of these regulations, and yet that was one of the things that showed up most commonly in people's preferences. So I think there may be things people want in terms of privacy that go well beyond what we're talking, what we even think of today in any of these law, much less what we do in research. And so I think it's a wide open area. Some other common things: context, location-based restrictions, query term, time-based restrictions. Yeah, I only want to share with my work group the things I actually do during work hours. I can give later, if you want to talk to me about it, I can give a very specific example of something going very wrong there. Anyway, any questions on this? I think we're pretty much out of time, but any questions, comments? Like I say, if you have thoughts, ideas, discussion, feel free to come talk to me at some point. And this is an open and I think a burgeoning area to be working in. Okay. Thank you.